Jupiter, the largest planet in the solar system. A stormy gas giant with no solid surface. 2.5 times as massive as all of the other planets combined. So how has this gigantic distant world protected our own home, and some say even made life on Earth possible? Welcome to Space School. Jupiter is the third brightest object in the night sky after the Moon and Venus. It has been observed since the dawn of man and was often called a wandering star by ancient peoples, baffled by its movement across the heavens. The planet is named for the Roman king of the gods, and for good reason. This Goliath has a diameter almost 11 times greater than the Earth. Jupiter, like Saturn, Uranus, and Neptune, is made up of gas and liquid and has no solid surface. Its gaseous material simply gets denser as you move inward. The planet is almost 90% hydrogen and 10% helium, with traces of methane, water, and ammonia. This composition closely mirrors the primordial solar nebula, the material the entire solar system was formed out of. Scientists can only theorize about the makeup of Jupiter's core, but it is thought to be solid, rocky, and as big as 10 to 15 Earth masses. Above the core is the bulk of the planet, a giant layer of liquid metallic hydrogen, a substance similar to the interior of the Sun, but much cooler. Despite its huge size, Jupiter completely rotates on its axis in less than 10 hours, faster than any other planet. The colorful bands we see across this planet are layers of atmosphere. The colors indicate the cloud's altitude. Blue are the lowest, then browns and whites, finally the highest, reds. The outer reaches of the atmosphere can dip to minus 200 degrees Fahrenheit. But traveling inward, temperatures rise precipitously. The temperature at Jupiter's core is estimated to be more than 35,000 degrees Fahrenheit, meaning this planet actually radiates more energy into space than it receives from the Sun. But these high temperatures are not due. They are the result of gravitational compression, the intense pressure on the core inherent to a very large planet. Jupiter would have to be at least 80 times more massive to become a star. Heat rising from the planet's core collides with the ice-cold atmosphere. The results are extreme and violent. Huge storms and hurricane-force winds roll across the surface. A gigantic storm is also behind one of Jupiter's most famous features, the Great Red Spot. First observed over 300 years ago, this oddity wasn't proven to be a storm until 1979, when the probe Voyager passed within 220,000 miles of the planet. Photos showed that swirling gases, resembling a hurricane, churns up the atmosphere at speeds close to 225 miles per hour. Strangely, this storm remains at roughly the same distance from the equator, drifting slowly east to west. But the storm is constantly changing in size, ranging from as small as the diameter of Earth to as much as 3 times as large. Jupiter may be almost 400 million miles from Earth, but it is key to our survival. Due to its massive size, and because of where it orbits the Sun in relationship to us, its gravity deflects many asteroids and comets headed our way. If Jupiter were not in our solar system, we'd be hit by an asteroid or comet every 10,000 years, instead of every 100 million. Jupiter's magnetic field is 14 times as strong as the Earth's. Protected from a constant bombardment from space, Earth was able to develop both simple and complex forms of life. In short, we owe our very lives to the planet Jupiter. Jupiter is millions of miles out in space, but it is not alone. It has, at last count, 63 moons. One of them, Ganymede, is the largest in the solar system. In fact, this satellite of Jupiter is even slightly larger than Mercury, and considerably bigger than Pluto. Ganymede and 3 other moons are close to the planet and spherical in shape, having formed around the same time as Jupiter itself. Europa, another one of the large moons, is awash in water. It has almost twice as much water as all the Earth's oceans combined, and is considered one of the hot spots in the solar system in the search for extraterrestrial life. Many other moons are tiny and irregular, some as small as just a mile in diameter. Most of these are probably asteroids ensnared by Jupiter's gravity. This was the first outer planet to be visited by a spacecraft from Earth. In the 1970s, both the Pioneer and Voyager missions reached Jupiter. Landing on a gas giant is, of course, impossible, as a space probe would be completely crushed by the immense atmospheric pressure. The first probe to venture beneath Jupiter's clouds was Galileo in 1995. It orbited the planet for nearly 8 years. Then in 2003, scientists deliberately crashed it into the planet to avoid the craft hitting any of Jupiter's moons, possibly contaminating them with bacteria from Earth. Any contaminants would destroy future chances of discovering life on one of those moons. 2011 will mark the launch of the next mission to this massive world. The spacecraft Juno will be put into orbit to study the earliest history and formation of this magnificent planet, the solar system's largest, Jupiter. This is Space School, signing off. Class dismissed.